This is 2020 AMC 10A Problem 19. As shown in the figure below, a regular dodecahedron, the polyhedron consisting of 12 congruent regular pentagonal faces, floats in space with 2 horizontal faces. Note that there is a ring of 5 slanted faces adjacent to the top face, and a ring of 5 slanted faces adjacent to the bottom face. How many ways are there to move from the top face to the bottom face via a sequence of adjacent faces, so that each face is visited at most once, and moves are not permitted from the bottom ring to the top ring? Now, there are 2 horizontal faces as stated in the problem. This one and the face at the bottom, which is really kind of invisible to us. And we want to move from the top face to the bottom face, but we can't just jump directly through the middle. We have to move on the outside of this dodecahedron, and you have to move along adjacent faces. And there are 2 layers. Layer 1 has 5 adjacent faces. So 1, 2, 3, 4, 5. 2 more at the back you can't see. These 5 faces are all adjacent to the top face. Layer 2 also has 5 adjacent faces. These 5 faces are adjacent to the bottom face. So let's just start from the top face and use something. So let's just start from the top face. Now, how many ways are there to move, go down? Because you can't go up. Because it says that movement is not permitted from the bottom ring to the top ring. So how many ways are there to do so? Well, 5 ways, because the only thing you can do really is just move down to one of the 5 faces. So let's say I move down to here. Okay, so now I'm here. Now what can I do? One thing I can do is move around. Right, so I can move around. So, however, sometimes I might not want to move around on this layer. I just want to proceed to the next layer. I just want to move down. So, how do I calculate this? This is the hard part of the problem. This is what people fall for. So, essentially just think about how many ways are there to move around. Notice that counterclockwise moving and clockwise moving are different. So in simple terms, moving to the left and moving to the right are different moves, because these are different faces. Or when you write it out, they're different sequences. So I can move one way of moving is I can move one face clockwise. Another way is move 2 faces clockwise, 3 faces clockwise, 4 faces clockwise. So there are 4 ways of doing so in clockwise motion. What about anti-clockwise? One face anti-clockwise, 2 faces anti-clockwise, 3 faces anti-clockwise, 4 faces anti-clockwise. Another 4 ways. So there's 8 ways in total. So times 8. Well, wait, that's not right. What if I don't want to move? What if I just want to move down? I don't want to move onto any other faces. We have to add 1, because there are 8 methods of moving plus 1, which is I'm just not going to move. I'm just going to stay here. 0 moves on the layer. I'm just going to stay here. So there's just 9 ways. So it's 5 times 9, not 5 times 8. So it basically means when I reach this face on layer 1, because I'm definitely going to go to layer 1, how much ways are there of moving or not moving? So there's 9 ways of doing so. Okay, so let's say I went to another face. Okay, I'm here. How much ways are there of moving forward? I'm going to move down now. I'm finished moving on this layer. I'm going to move down. Well, there are 2 ways of moving down. Because you see here, there are 2 sides adjacent to the bottom layer. So there's 2 faces adjacent. So there's 2 ways of moving down. Now, once I move down, so I move to here. How much ways are there of, continuing? Again, 9 ways on this layer, because I don't have to move. I can move here, move all the way around, or I can move clockwise, or I can move anti-clockwise. There are 9 ways again. And then finally, once I settle down and say I move to here, there's only 1 way left that I can move to the bottom face, because only one side is adjacent to the bottom face. So times 1, we don't have to write anything. So this is just 9 times 9, 81, times 5 times 2, 10, which is just 810 ways. And indeed, there is an 810 in our answer choices, so that's just our answer. Thanks for watching. Bye!